Hello everyone, welcome to Maths New Vision Physics channel. In this video, we will solve this question. Let's see the statement of this question. F and G are continuous functions on 0, 1 closed interval such that f of 0 is equal to f of 1 and f of 1 is equal to 0. G of 0 is equal to G of 1 and G of 1 is equal to 1 and f of 1 by 2 is strictly greater than G of 1 by 2. Then which of the following statement is true? Here we have given 4 statements. In options, only one statement is correct. Let's find. We have given two functions f and g, both are continuous on this closed interval, and we have given three conditions. In first condition, value of function f at the end points of this interval is 0, and for g, the value of g at this end points of this interval is 1 and f 1 by 2 greater है g of 1 by 2 से. Then which of the following statement is true? In first statement he says there is no t belongs to 0 1 such that f of t is equal to gt, means there is no elements in this closed interval for which these two functions are equal. In second option, there are only one element in this closed interval for these two functions are equal, and in third option at least two elements exist in this interval, and in fourth option always infinitely many elements exist in this interval for which f of t is equal to gt. Let's check. Here we see f of t is equal to gt, f of t is equal to gt. So we take difference of these two functions hx, f of t, f of x minus g of x. We have given f and g are continuous on this interval. In same domain, difference of these two functions is also continuous. Therefore, this h is also continuous because domain of both functions is same. So hx is continuous on 0, 1. Let's check the value of h at the end points of this interval. h0 means f0 minus g of 0, f of 0 0, g of 0 1, and this is equal to minus 1. 1, f of 1 minus g of 1, 0 minus 1 is equal to minus 1. At the both end points, value of h is same, minus 1. Let's check at 1 by 2 value of h. At 1 by 2, f of 1 by 2 minus g of 1 by 2. Since we have given f is strictly greater than g, therefore h is strictly greater than 0. Means value of h at 1 by 2 is positive. From these three and this, we can conclude these four options. Which one of these is correct? We draw graph 0, 1. For h, what we have seen, at value of h at 0 is equal to minus 1. This is minus 1 down, and for 1 this is also minus 1 down, and for 1 by 2 value of h positive, that value may be lie here anywhere, like this is here. Since function is continuous, if we draw a graph from this to this to this, graph does not break since h is continuous. In particular case, maybe graph like as. If we join these 3 points, we see this graph cuts the domain line at 2 points. This means there exist 2 zeros for h. But this is a particular case. The graph may be like as, and in that case this graph joins also these 3 points, but this has 1 2 3 4 1 2 3 4 zeros. From these two graphs we conclude that h has at least 2 zero. We can guarantee h has at least 2 zero. We cannot guarantee more than 2 zeros. We can guarantee only for 2 zeros. So therefore, from this discussion, third option is correct. There are at least 2 t belongs to 0 1 such that f of t gt. I tick this, but what we have seen, hx has at least 2 zero. At 2 zeros, suppose t is zeros. Suppose this point t gives 0 for h. Means at t this h gives 0. Means f of t minus g of t is equal to 0. F of t is equal to g of t. So we have at least 2 points in domain we can guarantee for which ht is equal to 0, and from this discussion we conclude there are at least 2 t belongs to 0 1 for which f of t is equal to gt. The questions completes. Thanks.